Okay, so I'm getting the recording started, but let's go ahead and I want to share this document with you first. So what we're going to do here is we are going to get some of that background knowledge again about the vaccines, right? So if you remember the very first week of the quarter, I wanted to talk about how the vaccine is different than previous vaccines, how the COVID vaccine is so unique. And so there's a couple of things we've learned about the immune system. In whole group yesterday, we talked specifically about things like neutrophils. We talked about T cells. They mentioned things like antibodies. And they kind of talked about how the immune system is called. It's a response, right? And so when an invader comes in and starts to attack, hi Logan, thanks for joining us. When we talk about how there are these red blood cells, they get attacked, and then it causes the white blood cells to then come and assess the situation and then call reinforcements depending on what is the invader, what is it, bacteria, viruses, so forth. And so when we have a situation like our immune system is responding, right, we start to remember what that particular invader looks like, shapes, all of that stuff. And that's when antibodies are formed. So we've been talking, and maybe you've heard a lot about antibodies over the last year because there was the antibody test for people who may or may not have already had COVID, right? And they wanted to see if they had it without having the test available at the time. So then they get the antibody test. So just seeing if your body has had it and produced the antibodies, which is how we remember any sort of virus or bacteria that enters our system. We learned a couple weeks ago about viruses. We learned in the lesson about bacteriophage, which was specific viruses that attack bacteria. And then in small group, we did learn about COVID, the virus, and how it attacks your body and how it specifically stays in your lungs, how it has those lock and key mechanisms that enters your body into your cells. And then because COVID is very specific, it's not a DNA virus, meaning that it needs to get into the nucleus and embed itself in your DNA in order for the mRNA to be made and sent out to your ribosomes to produce that protein synthesis. See, we're connecting so many things that we've learned this year, right? So biology is one of those concepts that even if you learn things separately, they're so interconnected. It's not a separate entity. It's not just protein synthesis. All these things relate to one another and affect each other, right? So when we talked about how we have viruses that come into the cells, what's unique, and one of the things that is unique about COVID is that it's an mRNA virus, meaning it already has its genes encoded in a format, in RNA, where you don't need to make the mRNA. It's already RNA. So it doesn't need to get to the nucleus. It just needs to get inside your cell. Once it's inside your cell, then it uses ribosomes, right, to read it and create the proteins that then create more viruses. And once it gets to a point where there's enough viruses, it can rupture the cell, and then it goes and attacks the other cells. And that's how this virus spreads. So we're going to learn about how the COVID vaccine is one of the first of its kind. And in the video that we're going to watch first, so let me go ahead and get the PowerPoint up. But the link that I put in the post, or excuse me, the link that I put in the chat is specifically going to be the graphic organizer that we're going to use in a little bit. So we're going to watch a video first. You know how I love my videos. And you know I feel strongly about my videos. And then we are going to have an opportunity to read a couple of articles that then you're going to analyze and make connections from past units that we've done. Okay, so I'm going to walk us through this PowerPoint really quickly. So we've got our COVID vaccine. We're going to make a hypothesis. We're going to then watch a video. We're going to read, and we're going to reflect. So that's what we have to look forward to today. So hypothesis, using your background knowledge of mRNA, protein synthesis, and now your background knowledge of viruses and immune system responses, how do you think the COVID vaccine works? Okay. And then use the space below to provide an explanation or draw a model. So what I was going to do, I will give you guys access to this. Well, I wanted you guys to draw it. So is this let me double check here really quickly. Is it? No, it's not. Okay. Let me go ahead and give, you know what? Let's do this. I like this idea. Why don't we turn on the whiteboard? So now I want you to hypothesize how, hi Spencer, I want you guys to hypothesize how the vaccine for COVID is going to work. So here, let me turn on the whiteboard, and I want all of, now you guys should all have access to it. So if you take a look, there should be a pencil that shows up right underneath the plus or minus of the of your zoom in on the whiteboard, and you should be able to draw. So let's draw our hypothesis. What do you think is going to happen to, oh man, I don't know what just happened. Anyway, or you can write your hypothesis, but ultimately we're hypothesizing. So how do you think a vaccine works? I'll draw the first thing. That's a needle. So I started the first step. Now what happens? What happens after you got the vaccine, right? We don't need to talk about the process, but we need to just talk about what happens when a vaccine is created and it gets what comes after it. It's in a needle already. Then what?
So is it just in the needle at this point, or has it been?
It is in the needle at this point.
No, it hasn't actually. Okay.
Nope, so, it's in the needle right there. That's the vaccine. Logan, what happens after the needle? There we go. Perfect. Great, great, great. Good. And that's, I'm assuming, an arm, right?
Yes, it's an arm.
Great, good. So then the vaccine goes to,
it's showing where to inject.
There it goes. Perfect. All right. Denny said it gets injected into us and then our bodies process it, and it works by helping our bodies produce antibodies and build up immunity. I think that is a really great explanation, Denny, in the overall sense. So yes, that is exactly what happens. So now that we have kind of our timeline theme, right? So if we think about this as like a story, we have our template. We know the overall summary of what's going to happen. So let's break it down, right? We said that it injects us, and then you said our bodies process it. So what does that mean when we're talking about the COVID vaccine in general, right? So remember that previous vaccines, they used to put, or not used to, there's still vaccines that do this. They put weakened bacteria or weakened viruses into your bodies so that our bodies can produce antibodies. But in this case, it's not a weakened one, right? So what is happening? How does our bodies process it? What does that look like? So I'm going to kind of do one of those like in the arm and then like it zooms in kind of things, you know? So who wants to draw in this circle what's happening once the vaccine is injected into the arm? Logan, what do you think? You can type it or you can draw it or you can talk about it. Yep, right after the injection, what do you think happens? And then Spencer, get ready because you're next. So after Logan explains what happens when the injection occurs, you're going to be ready to make a hypothesis of the next step. Okay, it gives our body the information of how to defend our bodies in the future by giving us a small sample. Good. So yes, it does give us a small sample, but remember what I said. I did mention that other other vaccines often put in a weakened version of the virus, right? But this vaccination is different, right? How is this different? It's one of the first of its kind. So how is this vaccine different than all other vaccines? That was a very, right? So what's different about this one than others? So like what kind of small sample is this going to give us?
Like from what part of the virus? Do you want a drawing or do you want a verbal?
Whatever your heart desires. And Spencer said, does it give you the cells that have an immunity?
That's not what I wanted.
It does. It gives the cells that have an immunity. So you're close. So you're in the right idea, the right ballpark. So let's take another minute or two on this hypothesis, and then we're going to watch a video that kind of explains it. And we'll kind of check with ourselves. But remember, I said that this vaccine is an RNA, or oh my gosh, virus is an RNA virus, not a DNA virus. So what do you think we use in our vaccines as well to create a type of vaccine? Good. Yep. Good. Yes. So what we're doing here is we are trying to create a spike protein, right? We're trying to recreate that spike protein that is so specific and unique to COVID. Remember when we watched our video a couple weeks ago in small group when we learned about COVID, we learned that it was considered a coronavirus because of the spikes on the outside of the virus. And that's how that lock and key mechanism works on our cells. And that's how the cells allow it to come in. So when we try, what we're trying to do is we want to give the body some sort of copy or version of it so that in the future, our bodies respond to it and already create that those antibodies so that when the real thing comes in, we're already armed and prepared because we know about it. We know what it looks like. So we're going to stop here with our hypothesis. And now what I want us to do is I want us to watch this quick video. And this video is going to give you an explanation as to how the virus works. So one thing that I want us to do when we're watching this video is I want us to, let me see if I can first get the link. Okay. So what I want you guys to be doing is I want you to please pay attention to key vocab and content that we've learned, and then take notes as you want. So really specifically, what I would like for you guys to do is pay attention. Is there anything that they say that you hear that we've already talked about in either quarter one or so far in quarter three? And you don't have to write down everything. You can just write down the vocabulary word. Maybe there's a phrase that they say that you recognize that we've learned before. You just want to write down the phrase so that when we're watching the video, I don't expect it to be notes on notes on notes. But really, I want you guys to start making connections of what we've learned to what we're about to listen to, okay? And then as we go through, you can take notes of the video, okay? It's not a very long video, so it's not going to take too much of our time, but I want us to be paying attention, okay? Are there any questions? Okay, all right, let's go ahead and watch the video. What did I do? There we go.
You may have heard a lot about mRNA vaccines recently. These
So that was a lot in a little bit of time. But what are some things that you was pointed out to you? What are some things that you heard that made sense to you? Now, of course, I don't necessarily expect for you to get everything in that 1 2.5 minute video, 3-minute video. But so far, what were you able to pick out from that? Spencer said, "Wow." Tell me about that. What do you mean, whoa? What like kind of blew you away there? That was just cool. Yeah. What science has been able to come up with is absolutely mind blowing. I mean, really, it's just, in one of our earlier videos, when we were first learning about the COVID, when we were learning about coronavirus last week or 2 weeks ago, it was an older video from, last year. So it was right when everything was starting to shut down. And they talked about how one of the fastest vaccine that was produced was in response to, oh my gosh, I can't remember what it was, but it took 5 years. That was record breaking at the time. And now we were able to not only create a vaccine in less than a year, but we were also to create a new one that didn't use weakened viruses. What does this vaccine use specifically? What does this vaccine inject into your cells? If it's not a weakened virus. Hi, Elias. So glad for you to join us. Do you guys want to watch it again, or do you want to watch one of these other ones? You can watch this one. Yes, it does. Good. Let's watch this one. Well, I really wanted. I want to let me choose this other video. Let's watch it one more time. Right there. What kind of vaccine is this? It just said it. What kind of vaccine is the COVID-19 vaccine? mRNA, exactly. So if it's an mRNA vaccine and we know about protein synthesis, what is unique about this vaccine? Then, like, what is going to happen when we inject the mRNA? What is the mRNA coding for specifically? Logan, what do you think? Okay. Dunny, do you have an idea? What the mRNA that's injected into our body, what is that specifically coding for? What gene is that telling the ribosome, or what protein is that telling the ribosome to make? Okay. Let's watch this video one more time. Yeah? Okay. So, what happened? You can't see the video? Okay, let's see. What if I do this?
Yeah, if you played it that third time or whatever, it didn't show at all.
Okay, what if I do, what about now? Can you see it now?
It's loading, so I think it's going to work.
Great.
Yeah, because we saw it the first time when it went all the way through, and then the second time when you had stopped it. But then if you tried to play it again, it didn't work.
Okay. Love it when things work. Now it's just loading, yeah?
Yeah, we just see the spinning wheel.
My internet's not great. Hold on. There we go. Is it playing?
It's spinning.
Still?
Yeah. So it's a black screen with just a white circle going.
What about now?
It's spinning. Because like when you got out,
Cells,
oh, now it's
or
going.
APCs. In
I wanted to restart it. Is it starting from the beginning now?
It's, I think at the begin, it's not at the beginning, but it's.
Does it say like mRNA vaccines and then a new type of vaccine being developed?
Yeah, but it says it's like 11 seconds into it, which is where I think we were to begin with.
Yeah, perfect. Okay, that's what I wanted. Great.
for COVID-19, you may wonder how
Okay, did you guys just see that? Okay, so what happens? What's the first thing that happens? Good, the lipids merge with the antigen cells. And what's inside the lipids? So remember the type of vaccine this is. So what's inside of the lipids that are being put into your body? The mRNA, exactly. Good. Okay, so let's continue. And tell me if I'm going to hit play. Tell me if it works. Okay. Good, Spencer. Good, exactly, right? And this is unique. Before, when we had vaccinations, we would just have a weakened vaccine, or excuse me, a weakened virus injected into our bodies that then elicited or started immune response. But instead, we were able to find out what the actual mRNA was for the code for what part. This mRNA is specifically going to go to the ribosome, where the ribosome is going to read it. So remember, it doesn't need to go to the nucleus, right? It already knows, it's already in an mRNA form. So it just needs to get inside of your cells. And once it gets inside of your cells, it's going to meet that ribosome. And we remember the ribosome as the factory, right? This is where proteins are made. And this was the part of DNA synthesis, or excuse me, protein synthesis, that our mRNA goes and our ribosomes start to make those proteins that are necessary for our body. But the ribosome just sees mRNA. They're like, cool, instructions. Let me just read it and build it. Let me just give me the next one. And so it's not checking to see what it's making proteins for. So the vaccine has these mRNAs and these lipid vesicles that get injected into your cells, and it goes straight into the ribosome, and your ribosome reads that mRNA and starts to create what? So yes, it is going to produce antigens, but specifically, in order for it to produce those antigens, it first needs to produce what? What is this mRNA coding for? What protein is it going to have the ribosome create? Do we know yet, or do we want to watch a little bit more? Okay, let's watch a little bit more. So what is that mRNA coding for? So when we get the vaccine, good, yes, we know that the antigen is going to stimulate an immune response, but that mRNA is coding for what particular protein that is found on COVID-19. It's on the, as long as the video is working correctly, it is on the screen right now.
It was what my beautiful picture was of.
Yeah. It's on the screen. The spike protein. Yes.
See, it was my beautiful picture. That's what
Yeah.
It was my beautiful drawing of a spike protein.
Yep. Exactly. It was actually a very beautiful drawing. And so we have the spike protein. So the vaccine is actually is not the virus itself at all, which is the first of its kind. We've always used a dead one or a weakened one or parts of a virus as part of the vaccine. But this time, we're not using the virus at all. Instead, what we're doing is we found out that specific part of the RNA that's encoded in the virus, and we manufactured it. And we put that into a vaccine, and that gets injected to us. So what's happening is the mRNA is going, that codes for the spike protein is getting injected into our arms, going to the cells, and then from there, it goes to the ribosome. So our ribosomes are actually producing the spike protein of COVID-19, but without having to inject COVID-19 into our bodies itself. And Logan, just like you said, that's when it starts to elicit an immune response. And that's when we have two different pathways. So I'm not going to show you the rest of the video because they talk about the two different pathways when they connect to the MC1 and MC2 proteins. But that really is just kind of this extra information that we don't necessarily need to know at this moment. So we have a basic understanding, right? We know that the vaccine is an mRNA vaccine that gets injected in the lipid. Now, what is a lipid? Remember what a lipid is? We learned about this in quarter one. So what are lipids considered? We eat, it's like our favorite thing to eat. It's what butter is, it's what avocado is considered. Fat, exactly. Lipids are fats. And so what we're doing is we're taking these little lipid vesicles, these little droplets of fat, and we're putting the mRNA. And once it gets into our system, it breaks down that layer of fat, allowing the mRNA to enter our cells. It goes from that to the ribosome. The ribosome reads the mRNA, creates those spike proteins, and that creates an immune response. And our body then sees that as an invader, starts to attack it, remembers it, and creates those antibodies. And those antibodies is what our body uses to say, oh, there's another invader. We've had this one before. Let's get him, guys. And that's how the immune system starts to get activated. Now, we're not going to watch more of this video. There are lots of videos on the internet that are really good at explaining it. I was looking for one that was a little quicker. So that's kind of the reason why I chose one that was kind of dense, but short. But we're going to go back to our presentation. And in this presentation, right, we're going to start getting to the part where we're going to be reading two articles. Now, the first article that you can read is a New York Times article. And it talks about specifically about the Pfizer vaccine and how it works. There's another article, USA Today, that also talks about the life cycle from DNA to doses. So it talks about the history about how these DNA vaccines or RNA vaccines, were created and the process that it went through for these companies to go through all of the checkpoints it needed in order for it to be approved and then delivered out to the masses. So I put in the article, the organizer, earlier, and I'm going to go ahead and put it back in there again. And I want you guys to create, well, actually, you know what? I take that back. Do not click on the one that I put in there. I mean, I already see a couple of you on there. But what I want you guys to do is actually click on this link, the new one that I just put into the chat, because that's going to generate a copy. So once you click on that, it's going to force you to make your own copy. So that way, when you type in it, it's not going to, affect my master one, which is the one that I gave you the first time. So you're going to click on that link, and then there are 4 of you. So that's great. We're going to put 2 of you in a room and 2 of you in a different room. So let's go ahead and put you guys into your groups. And then we will divvy out the articles. Okay, so let me put you into a breakout group. Not need 3 rooms, we just need 2 rooms. Why does it do that? Okay. All right, let's have room 1. So for room 1, so if you're in breakout group 1, you're going to be reading the New York Times article, which I'll put into your group. And if you're in group 2, you're going to be reading the USA Today article. Okay, so let's go into the breakout rooms. Hold on.
I was trying to.
Check the chat real quick.
Yeah. I was just saying if I was talking the right amount. I was trying to make sure I wasn't talking too much.
Oh, no. Perfect. Great.
Great.
It was perfect. Thank you.
Mm-hmm.
Which group do you want to go to?
I'll go to 2.
Okay. So for those of you who are not able to join us today, what I'd like for you to do is also look in the description box of this YouTube video where you'll be able to find the video that we watched explaining the COVID vaccine, as well as the document and links to the articles. And so now what you could do is you could be also completing the organizer, reading both articles if you would like, and have some time to reflect on it. Okay? All right. Thank you guys so much for joining us. If you have any questions, remember, feel free to ask and come to health sessions.